Imagine a shortcut through the universe, a bridge connecting distant galaxies. This is the concept of a wormhole, a fascinating and mind-boggling concept that has been the subject of countless science fiction tales and a topic of intense scientific debate. Wormholes, in essence, are theoretical passageways through space-time proposed by solutions to Einstein's field equations of general relativity. They are like tunnels with two ends, each in separate points in space-time, potentially linking extremely far distances, different universes, or even different points in time. Now picture this. What if these wormholes could connect distant galaxies? It's an intriguing thought, isn't it? Imagine being able to travel light years away in a matter of moments, stepping through a wormhole and emerging in a far-off galaxy, millions or even billions of light years from home. This is the kind of travel that wormholes could potentially make possible. However, it's important to note that wormholes are purely theoretical at this point. Despite being solutions to Einstein's equations, we have yet to find empirical evidence for their existence. They are a part of the exotic solutions to the equations of general relativity, which involve negative energy densities and other phenomena not yet observed in the natural universe. Despite these challenges, the concept of wormholes has gripped the scientific community and the public's imagination, providing a rich field for exploration in both theoretical physics and science fiction. They offer a window into the strange and fascinating world of quantum gravity, a realm where our understanding of the universe is still in its infancy. Now that we have a basic understanding of wormholes, let's delve into their theoretical workings. We'll explore the concept of the Einstein-Rosen bridge, the challenges associated with the study of wormholes, and the potentially revolutionary implications of their existence for space exploration and our understanding of the universe. At the heart of our understanding of wormholes lies the Einstein-Rosen bridge concept. Now, imagine you're holding a piece of paper and you want to get from one side to the other. The quickest way isn't to go across the surface, but to fold the paper in half and push a pen through it. That, in essence, is what a wormhole does. It's a tunnel that shortcuts through the fabric of space-time, connecting two distant points. Wormholes are solutions to the equations of general relativity, the theory proposed by Albert Einstein. This theory describes how massive objects like stars and planets create a sort of dent in space-time, which we experience as gravity. Now, if space-time is flexible enough to be dented, it's theoretically also flexible enough to be twisted and stretched into tunnels or wormholes. The name wormhole comes from an analogy used to explain this concept. Picture a worm crawling along an apple. It could go the long way around, or it could simply burrow straight through to the other side, much quicker. But here's where things get tricky. The Einstein-Rosen bridge, the technical term for a wormhole, suggests that these tunnels are incredibly unstable. They would require some form of exotic matter with negative energy to keep them open. Without it, they'd snap shut as soon as they formed, trapping anything that entered. In other words, wormholes could exist in the universe, but they might be more akin to cosmic mousetraps than intergalactic highways. It's not exactly the Star Trek vision of zooming from galaxy to galaxy, but it's fascinating nonetheless. While fascinating, our current scientific understanding of wormholes is still limited. Theoretical physics provides us with a compelling framework to explore these concepts, but we're far from having a complete picture. Wormholes remain a tantalizing mystery at the frontier of our understanding of the universe. The study of wormholes involves navigating a landscape filled with uncertainties and challenges. In the realm of theoretical physics, wormholes are still largely a mystery. We understand them as shortcuts through space-time, a concept predicated on Einstein's theory of general relativity. Yet, their existence remains purely speculative, with no empirical evidence to validate their presence in our universe. Furthermore, the understanding of wormholes is complicated by the fact that they're predicted to be highly unstable, collapsing instantaneously unless some form of exotic matter can be used to stabilize them. This exotic matter, theoretically capable of negative energy densities, is yet another enigma in the scientific community. Adding to the challenge is the fact that wormholes, if they do exist, would likely be microscopic, making them virtually undetectable with our current technology. These uncertainties create a complex puzzle that scientists are diligently working to solve. Despite these challenges, let us explore the implications of wormholes connecting distant galaxies. Wormholes connecting galaxies could revolutionize our understanding of the cosmos. Imagine a universe where the vast distances between galaxies are no longer a barrier, where travel from the Milky Way to Andromeda isn't a journey of 2.5 million light-years, but a trip that could, theoretically, be as short as stepping through a door. This is the extraordinary possibility that wormholes present. Wormholes, as predicted by Einstein's theory of general relativity, are shortcuts through space-time, tunnels that can link two distant regions of the universe. If such cosmic bridges do exist and could be navigated, they could open up unimaginable opportunities for space exploration. We could potentially reach regions of the universe that are currently far beyond our reach, in timescales that are humanly conceivable. But let's not get ahead of ourselves. The existence of wormholes is still purely theoretical, and even if they do exist, there are significant challenges to overcome. The intense gravitational forces within a wormhole could crush any spacecraft attempting to pass through. They could also be incredibly unstable, collapsing the instant anything tries to enter. Despite these challenges, the idea of wormholes connecting galaxies is tantalizing. It could open up a whole new era of space exploration, allowing us to study distant galaxies up close, and perhaps even meet extraterrestrial life forms. It could also have profound implications for our understanding of the universe. If wormholes can connect distant galaxies, then the universe could be much more interconnected than we currently believe. But perhaps the most exciting possibility is that wormholes could enable intergalactic travel. This connectivity could potentially transform the way we travel through space. Instead of voyaging for thousands of years to reach a distant star, we could simply step through a wormhole and arrive in an instant. Such a breakthrough would truly be a game changer, opening up the universe to human exploration in a way we can barely begin to conceive. Traveling through galaxies might no longer be a far-fetched idea with the existence of intergalactic wormholes. Imagine the universe as a vast cosmic ocean, and wormholes as the secret undercurrents that connect distant shores. These cosmic shortcuts could potentially provide a rapid transit system between galaxies, revolutionizing our understanding of space and time. This would open up a whole new realm of possibilities for the exploration of the universe. We could venture into galaxies billions of light-years away, explore celestial bodies we've only glimpsed through telescopes, and perhaps even meet extraterrestrial civilizations. The impact of such a discovery would be immeasurable, reshaping our perception of our place in the cosmos. Yet, while the prospects are exciting, they are not without challenges. Traveling through wormholes would require us to overcome immense gravitational forces, navigate through space-time distortions, and ensure the stability of these cosmic tunnels. However, such travel would require navigating and stabilizing wormholes. Traversing wormholes is not as simple as walking through a door. It's like trying to navigate a ship through a stormy sea, where the waves are made of space-time itself. Wormholes, in their most basic form, are unstable. They're like cosmic sandcastles that collapse as soon as they're formed. To navigate through these cosmic shortcuts, we would first need to stabilize them. Theoretical physicist Kip Thorne suggested that a form of exotic matter with negative energy could hold a wormhole open. But here's the rub. Such matter has never been observed in the universe. We need to invent new technologies or discover new physics to overcome this hurdle. Even if we manage to stabilize a wormhole, navigating through it would be a daunting task. Wormholes could potentially connect not just two different points in space, but also two different points in time. They could lead to a different galaxy, or to the other side of the universe, or they could lead to a completely different era in cosmic history. Additionally, the journey through a wormhole might be fraught with danger. Imagine getting sucked into a cosmic whirlpool, or being stretched and squeezed by intense gravitational forces. The forces inside a wormhole could be so strong that they rip apart anything that attempts to pass through, including a spaceship or a human body. There's also the risk of getting lost in a maze of wormholes. If wormholes can connect any 2 points in space and time, who's to say they can't connect to each other? Navigating through a network of wormholes could be like trying to find your way out of a labyrinth that exists in 4 dimensions, not just 3. Despite these challenges, the benefits of intergalactic travel could be immense. Imagine being able to reach the farthest corners of the universe in the blink of an eye. Imagine exploring distant galaxies, discovering alien civilizations, and unlocking the secrets of the cosmos. The journey may be perilous and the destination uncertain, but the rewards could be beyond our wildest dreams. The existence of wormholes could influence the dynamics and evolution of galaxies. Now, let's dive into the cosmic dance of galaxies. Imagine wormholes as cosmic shortcuts connecting distant parts of the universe. This could completely rewrite our understanding of galactic behavior. In a universe where wormholes are prevalent, the gravitational interactions between galaxies could become more complex. For instance, the matter and energy transferred through wormholes might affect the formation and life cycle of stars. Even more fascinating, black holes, those mysterious cosmic entities, could be influenced. Could a wormhole stabilize a black hole or perhaps trigger its creation? The possibilities are as vast as the universe itself. Also, wormholes could create cosmic pathways for celestial bodies. A comet from another galaxy, for instance, might find its way to ours through a wormhole, altering our galactic neighborhood in unpredictable ways. The implications of wormholes extend beyond space travel to even potential extraterrestrial contact. Intergalactic wormholes could open doors to civilizations beyond our galaxy. Imagine the possibilities. We've always looked up at the stars and wondered if we're alone in the universe. The potential existence of wormholes connecting distant galaxies could mean that we're far from alone. The concept of extraterrestrial life has always been a topic of fascination. From science fiction to serious scientific research, the potential for life beyond Earth has captured our collective imagination. Now, consider the implications of wormholes in this context. These theoretical shortcuts through space-time might not only allow us to traverse the cosmos, but also facilitate contact with extraterrestrial civilizations. Picture this: a vast cosmic network of wormholes linking galaxies across the universe. This network could serve as a conduit for the exchange of matter, energy, and perhaps even information. This could mean that civilizations in distant galaxies could be communicating and interacting with each other through these intergalactic pathways. The implications are mind-boggling. An interconnected universe could lead to a cosmic melting pot of civilizations, each contributing to a grand tapestry of intergalactic culture. We could learn from the successes and failures of civilizations that have existed for eons before us. Moreover, we could share our own knowledge and experiences, contributing to the collective wisdom of the universe. Of course, this is all purely hypothetical. The existence of wormholes is yet to be proven, let alone the presence of extraterrestrial civilizations. But the mere possibility of such a scenario is enough to fuel our curiosity and drive our search for understanding. The exploration of wormholes and the potential for extraterrestrial contact represents a new frontier of scientific inquiry. It pushes the boundaries of our knowledge and challenges us to rethink our place in the cosmos. The potential scientific discoveries that could arise are beyond imagination. The concept of wormholes connecting distant galaxies has far-reaching implications for our understanding of the universe. These theoretical tunnels in space-time, as postulated by the Einstein-Rosen bridge concept, could revolutionize not just our approach to space exploration, but also our perception of the cosmos. Imagine, for a moment, the possibility of wormholes enabling rapid transit between galaxies. The sheer vastness of cosmic distances, once a formidable barrier, could become traversable, bringing distant galaxies within our reach. This potential for galactic connectivity could dramatically impact the exchange of matter, energy, and information across the cosmos. Yet, the journey through these cosmic shortcuts is not without its challenges. Theoretical and practical obstacles abound, from stabilizing the wormholes to navigating them. Time dilation and relativity add another layer of complexity, with travelers potentially experiencing time differently than observers. The existence of wormholes could also influence the dynamics and evolution of galaxies, impacting star systems, black holes, and other celestial bodies. And let's not forget the tantalizing possibility of extraterrestrial contact, facilitated by these intergalactic bridges. Harnessing wormholes for travel would demand significant technological advancements, with potential earth-shattering impacts on life as we know it. And as we venture into this new frontier, we must also grapple with the ethical considerations associated with intergalactic exploration. The potential scientific discoveries that could arise from exploring distant galaxies through wormholes might reshape our understanding of the universe. From the nature of space-time to the mysteries of dark matter and energy, the knowledge we could gain is boundless. In conclusion, while wormholes remain largely theoretical, their potential implications are truly mind-boggling. As we continue to probe the cosmos, the mysteries of wormholes represent an exciting frontier in our quest to understand the universe. As we continue to explore the cosmos, the mysteries of wormholes remain an exciting frontier in our quest to understand the universe.